warahmatullahi wabarakatuh. My name is Muhammad Afif Ahmad Nawawi. My metric number is CF220035. So this is my structure bridge located at E50.
This structure is built using a steel and a concrete material and is built to span a physical barrier like a drain and provide a passenger over it. For a body diagram, my structure length 5 meter and the head is 2 meter. The structure has 14 kN per meter loads on it. The support reaction for the bridge is a pin and roller. Next is a centroid of the structure. To get centroid of my structure, I use a formula X equal B divided by 2, Y equal H divided by 2. So the location of centroid for my structure is X-axis is 2.5 meter, Y-axis is 1 meter. Moment of inertia of the structure. To get moment of inertia for my structure, I use a rectangle formula. Ix equal BH power of 3 divided by 20. Iy equal B power of 3H divided by 20. So we get a final answer is Ix equal 3.33 mm. Iy is 20.83 mm. For the conclusion, I assume the uniform distributed load is 14 kN per meter, the length distance is 5 meter, height 2 meter, and the kind of support reaction is identified as pin and roller. The centroid of the structure is now determined as X-axis of 2.5 meter and a Y-axis is 1 meter. Meanwhile, the stress in the slab for this structure has been determined for the moment of inertia. If Ix equal to 3.33 mm and Iy equal to 20.83 mm. With the data gathered through computation, the bridge is safe for all nutrition students to traverse.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nabil bin Kamaluddin. My metric number is CF220044 and this is my structure, column and beam. This structure is located at Perwira. Both structure, column and beam are used in the construction to support load and distribute load from the building.
For free body diagram of this structure, it has 6 kN load. The support and reaction of this structure is pin and roller, and the length of this structure is 12 meter and the height of this structure is 2 meter. For the centroid of structure, X equals to total AX divided by total A equals to 168 divided by 24, and the answer of X is 7 meter. For the Y, total AY divided by total A equals to 96 divided by 24, and the answer for the Y is 4 meter. The moment of inertia of this structure, total Ix equals to 3,792 meter, and then for the total Iy equals to 1,848 meter. For the conclusion, this structure is located at College Kediaman Luar Kampus Perwira. A beam is a horizontal structure element used to span and transfer load over a longer distance, whereas a column is a vertical structure element used to support and transfer load from building to its foundation. Both beams and columns play critical roles in the structure and structure stability and support, and which to use depends on the specific requirement of a given project.
Assalamualaikum and hi, my name is Malakira binti Hanwa. My matrix number is CF220245. Today I'm going to make a video for my static and dynamic subject. The building structure that I choose is roof. Okay, so part of a building envelope, which is the covering on the uppermost part of a building home. The outer layer of a roof varies depending on the availability of material and the nature of the supporting structure. The process of building and maintaining the roof is called as roofing. So as we guys know, we have a different type of tile roof with a different type of material. As what I choose now is a resting hut in UTHM. The material used is clay and concrete tile roof. It can last for 40 to 50 years if it's maintained properly. And lastly, of course, we have the pros and cons of roofing. So for the pros is, clay and concrete tiles are long-lasting and non-combustible, and concrete tiles are energy efficient. For the cons, clay and concrete tiles are expensive, heavy, and usually require additional framing. That's all from me. Thank you.
Good evening. My name is Muhammad Ednil bin Yusri. Today I will present to you my structure for our report for static and dynamic, which is electric pole. The purpose of this report is to analyze the static and dynamic behavior of an electric pole as a structural system. This electric pole is located at Powira Resident College. The report will focus on the key structural parameters such as support direction, centroid, and moment of inertia that determine the static and dynamic behavior of electric pole. The report will provide an in-depth analysis of this parameter. This is my free body diagram for my structure electric pole. Electric pole has only one support, which is fixed. It has 8-meter high and 0.5-meter wide. It has two forces for each side, and each forces has 200 Newton force. Next, we will continue to calculate the support direction of the structure. For Ry, we will assume it becomes 0 because there is no forces at y. For Rx, 200 plus 200 minus 200 minus 200, it will become 0. For moment, Ry will multiply by 0 plus Rx multiplied by 0 plus 200 multiplied by 6.8 plus 200 multiplied by 7.6 minus 200 multiplied by 6.8 minus 200 multiplied by 7.6. So the moment will become 0. For the centroid of the structure, x equal beam over 2 or width over 2, so 0.5 over 2 will be 0.25. For y equal h over 2, which is height over 2, so 8 over 2 will become 4. So the centroid of the structure is at 0.25 meter for the width and then 4 meter at the height. And now we will continue to calculate the moment inertia of the structure. For rectangle, the formula for inertia x is beam multiplied by height cube divided by 12. For Iy, beam cube multiplied by h divided by 12. To calculate the Ix, 0.5 will multiply with 8 cubed and then divided by 12. It it will be equal by 21.33 meter power by 4. For Iy, 0.5 cubed multiplied by 8 and then divided by 12, it will become 0.823 meter power by 4. In conclusion, the analysis of the static and dynamic behavior of an electrical as a structural system is crucial for ensuring the safety and reliability of the electric power transmission and distribution network. This report evaluates the key structural parameters of the electric core, including support reaction, centroid, and moment of inertia, which play a critical role in determining the stability and dynamic response of the structure. The support reaction, calculated as Rx and Ry, were found to be Rx equal to 0 Newton and Ry equal to 0 Newton, and the moment equal to 0. The centroid of the structure was determined to be located at x and y, which is 0.25 and 4 meters from the bottom left corner of the structure. The moment of inertia was calculated to be 21.33 meter power by 4 on inertia at x and 0.833 meter power by 4 on inertia at y. That's all for me. Thank you.
Hello, Assalamualaikum. My name is Rohiman bin Ruslan. My matric number is AF220057. So today I will present for the subject static and dynamics, the gate structure. First one is introduction. The gate is a part of a fence or outside wall that is fixed at one side and opens and closes like a door, usually made of metal or a wooden strip. It is a movable framework or solid structure, especially one that swings on hinges, controlling entrance or exit through an opening in a fence or wall. Rolling gates are primarily used for chain link fences in order to minimize the amount of space used by the gate. This gate slides parallel with the fence line using a track and wheel system. Gate frames are welded and, depending on the size, may also be branched and flush. Finished size of gate must be wider than the opening size to account for the rear wheels, which are bolted to the gate frame. Point number 2 is free body diagram of the structure. As you can see on the image below, the width of the structure is 5.7 meter and the height of the structure is 1.45 meter. Support reaction of the structure. The total MA is equal to 0. MA equal to NB bracket 4.71 minus 20 multiplied by 9.81 and 2.85 equal to 0. So the answer NB is 118.7 Newton. The second is MB equal to NA bracket 4.71 minus 20 multiplied by the 9.81 and 2.85 equal to 0. So NA is 118.7 Newton. Next point is centroid of the structure. As you can see, the width of the gate is 5.7 meter and the height is 1.45 meter. So we can use the formula below. S equal to B over 2 equal to 5.7 over 2. So we can get the answer is 2.85 meter for the S, and Y equal to H over 2 and equal to 1.45 over 2. So we can get the answer is 0.725 meter. Moment of inertia of the structure. This moment we can use the formula on the left picture. On the right picture is the calculation. Is equal to 5.7 bracket 1.45 cube over 12. So the answer is 1.45 meter to the power of 4. And the Iy is equal to 5.7 cube bracket 1.45 equal to 12, and the answer is 22.38 meter the power of 4. And the last for my presentation is conclusion. To be conclude, analysis of the structure, centroid of the structure, and moment of inertia of the gate is very crucial to know that the gate can stabilize and stand alone by itself. Gates is a very important part of some building like houses, schools, and hospitals to ensure that the border of each building can be accessed for people to get inside or outside. This report shows that separation of the gate is MA equal to 0 and NA equal to NB and equal to 118.7 Newton. Then, centroid of the gate can be determined as XY equal to 2.85, 0.725. Moment of the inertia of the gate was calculated to Is equal to 1.45 meter to the power of 4 and the Iy equal to 22.38 meter to the power of 4. So thank you so much.